Hey guys. All right, moving along in this unit over here. Next topic is called adding and subtracting rational expressions. So far, we've done reducing rational expressions. It's kind of how you just reduce a fraction. And then we did multiplying and dividing, and just by factoring and then canceling out common factors in the numerator and denominator. Now we're going to work on adding and subtracting rational expressions. So first, just a bit of review on fractions. Now, hopefully, guys, that we all realize that this is the incorrect answer. Okay, so if I have 1/2 plus 1/3, it's not as simple as adding the numerators and adding the denominators. Okay, this is not true over here. What we need to do is we need to get a situation where we're actually getting common denominators. So if I have a 1/2 and a 1/3, well, this denominator needs an extra 2 in it. So I'm going to go times 2 times 2. So now they both have a 2 in it. And this denominator here needs an extra 3. So I'm going to multiply a 3 to the top and the bottom. So it's going to do the same thing as 3 over, well, 2 times 3 is 6. And then we get times 2 over 6 like this. So the next thing is once we have common denominators, it becomes 3 plus 2 over 6. So you can add the numerators. 3 plus 2 is 5, but you keep the same denominator over here. So this answer is going to be 5/6. Okay. For the next one over here, I'm just going to do this one in a slightly different way. I'm just going to do a bit of, I'm going to factor this one as well. This is the same thing as 5 over 4 times 3 plus 3 over 4 times 2. Okay, so if you look at this, these guys already have a 4 in common, but we need to get a 3 over here, and we need to get a 2 over here. So I'm going to go times 2 times 2, and then times 3 times 3. So now it's 4, 3, 2 in the bottom, and 4, 3, 2 in the bottom over here. So it's going to be 10 over 4 times 3 times 2 is 24, plus 9 over 24 is 19 over 24, and that would be my answer for this guy here. So we need to get common denominators, and then we can add the numerators, keeping the same denominator for adding, and same thing for subtracting fractions as well. All right, so example 2, add, state any NPVs. So if I have 5 over x plus 3 plus 2 over x plus 6, okay, first thing I want to do is factor everything that we can. Well, there's nothing we can factor in the first term, but in the second term, we can factor out a 2 out of the denominator like this. Okay. Now let's deal with our NPVs right away. NPVs, x cannot equal -3, and that's coming from this one over here and this one over here. Okay, so when we're looking at this, what's going to make us common denominator? Well, the x plus 3s are already common, but this guy needs an extra 2 in it. So 2, a 2, like this. Okay, so we get 2 times 5 is 10 over 2x plus 3 plus 7 over 2 times x plus 3 like this is 10 plus 7 is 17 over 2 times x plus 3. Okay, so we leave this answer like this. You might see answers written in this form as well. Okay, these are both equivalent. I just multiplied the 2 through. I'm definitely okay with you leaving your denominators factored like this. All right, same idea. So we have 4 over x plus 7 plus 2 over x minus 1. So in this case, there's nothing to factor. Okay, but what we need is so this is an x plus 7, this is an x minus 1. So in other words, I want to have an x minus 1 in this guy, and we need to have an x plus 7 in this one over here. So what we're going to do is we're going to have an x minus 1 in the top and the bottom here, and we want to have an x plus 7 on this term. All right, so now if I multiply this through, we get 4x minus 4, and it's going to keep the bottom factored. X plus 14, keep the bottom factored. And now we can add 4x plus 2x is 6x. -4 plus 14 is 10 over x plus 7, x minus 1. Okay, our non-permissible values, -7 and +1. And we're going to have our non-permissible values listed right there. Okay. Similar idea, it's a little bit more difficult for example 4. So we have x over x minus 2 plus x minus 5 over x squared minus 4. So a strategy for this is when we can, factor everything we can. Well, we have an x squared minus 4 here. Which is a difference of squares. And we have this. So we have an x minus 2 here and x minus 2 here, so those are common. We need to get an x plus 2 over here. So I'm going to multiply the top and the bottom times x plus 2 and x plus 2. Okay, so now we have common denominators. I'm just going to multiply the top through. This is x squared plus 2x. I'm going to keep the bottom factored. Okay, and now we can add our numerators. So we have x squared, 2x plus x is 3x minus 5 over x plus 2, x minus 2, x cannot equal plus or minus 2 for the negative 2 here and the positive 2 for this one here. All right, example 5. Similar idea over here. Step 1, factor everything we can. X minus 6. This goes to x minus 6, x plus 1, plus x over x plus 1, x minus 1. I'm just going to list my non-permissive values right away. We have 6, and we have negative 1 and positive 1. Like that. All right. Now, just a quick little strategy here, which can make this easier, is in this case, well, if I have an x minus 6 and an x minus 6 here, I can just do that and cancel those guys out. Okay, so this can make this question a lot easier because now I have 1 over x plus 1 plus x over x plus 1, x minus 1. So now we have an x plus 1, which is already common, but we need an x minus 1 in the denominator here, like this. So we get x minus 1 over x minus 1, x plus 1, plus x over x plus 1, x minus 1, which is, I can add my numerators now, 2x minus 1 over x plus 1, x minus 1. All right, so we've stated our non-permissible values, we've kind of factored everything correctly, and we've added these ones correctly as well. Guys, I hope this makes sense, and please let me know if you have any further questions. Talk soon.